Class. I decided to make you a video since we didn't finish the lesson in class on Tuesday. So this is my own video for you all. You don't have to watch the video with the loud music in it. You can just watch this one, but if you want to watch that one as well, that's fine too. So we're going to talk about two concepts, multiples and least common multiple. Let's start with talking about multiples. I think you know what multiples are, but let's talk about the multiples of 3. They're basically all the numbers that when you multiply times 3, that gives you a multiple. So if we go in order, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, etc. We could even do 3 times 12 is a multiple of 3. Multiples of 5. It's just like counting by 5s. 5, 10, 15, 20. And if we took 5 times 10, we would get 50. 50 is a multiple of 5. So the first question, we're just basically reversing it. It says the number 8 is a multiple of which numbers? So which numbers, when you do this to them, you would eventually get 8. Another way of saying is what two numbers can we multiply together to give us 8? So they're basically the factors of 8. So it would be 1 goes into 8, 2 goes into 8, 4 goes into 8, and 8 goes into 8. 8 is a multiple of 1, 2, 4, and 8, which basically is saying 1 times 8 gives you 8, 2 times 4 gives you 8, 2 times 4 gives you 8, and 1 times 8 gives you 8. So these are the numbers. You can multiply them times something to give us 8. I don't think they have many questions like this one, so I don't want to spend too much time on that one. Now, the rest of the questions, this next one is easier. It says find the multiples of 9 that are less than 50. So we're just going to start with 9. 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. 9 times 5 is 45. 9 times 6 is 54, which is bigger than 50, so we're going to stop. These are the multiples of 9 that are less than 50. That's all you do. You just start multiplying 1, 2, 3, 4 until you hit a number that's bigger than 50, and you have to stop before you get there. All right, the next one's where we're going to get a little bit more complicated. That's why I wanted to do this video, to talk about how to find the least common multiple of bigger numbers. So eventually we're going to be adding fractions in this book, and we're going to have denominators, and we're going to need to find common denominators. Like, I'm just looking through the book, seeing if I could find one, like what's going to happen. If not, if I don't find it in a minute. Just think of this one. Like, what if we were adding fractions like 1/3 plus 1/4 plus 1/6? We would need to find what's called the least common denominator, which is the same thing as the least common multiple. It's the number that 3, 4, and 6 will all go into. And when you guys are looking at this, you probably know that the number that 3, 4, and 6 all go into would be 12. Now the way you can look at it is we would have 3, if we did the multiples, 3, 6, 9, 12. Let's do the multiples of 4. 4, 8, 12, and 6, 12. The least common multiple would be 12. And that's what we're going to be finding, the smallest number that all these numbers, the 24, the 55, and the 80 divide into. This is the smallest number that 3, 4, and 6 divide into is 12. And we could just do that because we can figure it out. But eventually the numbers are going to be so big that you can't just look at that and try to figure out what they're all going to go into. So we're going to use our good old prime factorization to figure out what the least common multiple is. So these are the steps. We're going to make trees, or you can do your division thing that you guys like to do. And we're going to break these into the prime factors. See, we need these. That's why I'm trying to teach you guys how to do these. So 24 is 2 times 12. 12 is 2 times 6, and 6 is 2 times 3. When you get down to a prime number, hopefully you know the prime numbers, 2, 3, 5, 7, 11, 13, etc., you are done. So you can circle them, and those are the prime factors of 24. So over here, I'm going to write these down. 24 is 2 times 2 times 2 times 3. And I'm going to do the same thing with the other two numbers. So 55 is 5 times 11. We already hit their prime numbers. So I'm going to write that over here. This is what you're going to do as well. 5 times 11. And then we're going to do 80. 80 is a bigger number. So we get 2 times 40, 2 times 20, and 2 times 10. We're still going. And 2 times 5, we can't go any further. So these are all the prime numbers at the bottom. We have 4 2s and a 5. So let's write that over here. So 80 would be 4 2s. 1, 2, 3, 4. I know you guys want to do 2 to the 4th power, but hold on. Just do what I do right now. Okay, now to find the least common multiple, it's a little tricky. And as we go, I'll help you to understand what we're doing. But today we're just going to learn the process. So we're going to take our first number, 24, and I'm going to copy down their prime numbers. 2 times 2 times 2 times 3. All of these numbers are so far in our least common multiple. So that means 24 is in there. That's 24. Now I'm going to go to the next number, and if the 5 was down here, we wouldn't have to add it, but it's not down here, so we need to add. We're not really adding, we're multiplying. And then we're going to multiply by 11. So now, so far, the 24 is in here. So if we wanted to divide this by 24, this would all cancel out, and we would get 55. And the 55 is all in here. See that? Now let's see if the 80 is in there. I'm just going to erase these again. So let's go to the 80s. We need 1, 2, 3, 4 2s. Well, look, we only have 1, 2, 3 2s. So we don't need to re-add those 2s. They're already down there. We're trying to get the smallest number that they'll all go into. Now we need to put this 2 in here because I'm just going to sneak it up into the front because this number needs to have 4 2s and a 5, so we have this 2 in there, and now the 5 is in here as well, so we don't need to multiply it by the 5. And this will end up being our least common multiple. If we multiply those all together, it's going to be a really big number. It's going to be 2,640. So what we know about this number that we just made, it's the smallest number that 24 will go into evenly, 55 will go into evenly, and 80 will go into evenly. Now, the next problems are partially done for you. They're kind of out of order a little bit. So this one has a number that's already factored, prime factored. 3 numbers that are already prime factored. So the first question is, what are the numbers? So basically, you have to multiply those all together. So I multiplied them all together already, and I got 588 is the first number. The second number is 560. And the third number is 1,250. Big numbers. So we are going to find the number that all 3 of these will divide into evenly. Obviously, it's going to be a very big number. We need the number that they're all going to go into, so it has to be at least bigger than 1,250. Now we're going to do the same thing that we did above, only they already did your factor trees for you. So we're to find our least common multiple. The first thing we're going to do is we are going to write down the first number, the prime factorization of the first number. So I'm going to write down 2 times 2 times 3 times 7 times 7. All of these numbers are included, so I'm crossing them out. Okay, the next one, we need 1, 2, 3, 4 2s. We only have 2 2s here. So we already have those 2 2s, and we already have a 3, but there's no 3, and we already have one of the 7s. So the 7's already in there, so we don't need to add any more 7s. But we do need to add 2 2s, and we need to get this, so we added those 2 2s, and we have to multiply in there a 5. When I say add, I mean multiply by, but it's just, we're adding it onto the list. Okay, let's go to the third number. There's a 2 already down there, so we don't need to add an extra 2. There's this 5, So we have 1 5, but this number needs 3 more 5s. So I'm going to multiply 3 more 5s onto the end. And so all 3 of these numbers, their parts are down here. We don't have any bonus numbers. We don't need to repeat anything. If it's already down there, we don't need to add it. But if it's not to complete the number, we need to make sure we put it in there. So when we multiply this all out, we are going to get 1,470,000. This, boys and girls, is the number, the smallest number that 588 will divide into, 560 will divide into, and 1,250 will divide into. It's our least common multiple. If we were to take 588 times 2, 588 times 3, etc., this one times 1, 2, and 3, and this one times 1, 2, 3, the whole way up, we wouldn't get a common multiple until we hit 1,470,000. All right, let's do a couple practice problems. These are actually the practice problems in your homework set, just to reinforce these concepts. So here we go. Finish out the video. So we want to find all the multiples of 7 that are less than 56. So we're just going to start multiplying 7 by 1, 7 by 2, 7 by 3, 7 times 4, 7 times 5, 7 times 6, 7 times 7, 7 times 8 is 56, but it says less than 56, so I am not going to put 56 down because it's not less than 56, it's equal to 56. So these multiple ones should be pretty easy for you. All right, this one's a little bit more specific. It says find all the multiples of 6 that are greater than 29 and also are less than 50. So we could start with 6 times 1, 6 times 2, 6 times 3, 6 times 4. They're all less than 29, so they don't count. 6 times 5 is the first one that's greater than 29. 6 times 6 is 36. 6 times 7 is 42. 6 times 8 is 48. And if I did 6 times 9, it would be outside of the 50. It would be too big. So these are our numbers that are multiples of 6 that are greater than 29 and less than 50. Okay, and here we go. My favorite problem of the day. We are going to use the product of prime numbers to find the least common multiple of each group of numbers. So let's do the first one. Make sure I have space down here. So we'll do the first one at the top and then I'll go down and do the second one. So we're going to prime factor our numbers using the factor tree or your little division bar things. So we have 2 times 9 and 3 times 3. So 18 is equal to 2 times 3 times 3. Let's do 250. So 250 is equal to, let's prime factor this, it's going to be 2 times 125, and then it's going to be 5 times 25. I can slide this down just a hair, and then this is going to be 5 times 5. So 250 is equal to 2 times 5 times 5 times 5, which is basically 125 times 2 is 250. Now, to find the least common multiple, I'm going to do it right smack in the middle here. Least common multiple. It's going to be equal to, we need all 3 of these numbers. So we're going to get 2 times 3 times 3. So it's these numbers right here. Now we're going to go to the next number. If it's already in our, let me just block this off a little bit. Okay, if it's already down here, we don't need to re-multiply it in. So the 2 is already in here. So we don't need to put another 2 in the line. We don't have any 5s, so all 3 of these 5s need to go in here. Now we have 5, 5, 5. So 18 is represented. There's 18 representing itself. And 250 is representing itself by having a 2 and 3 5s. So when we multiply that number together, we would get, let's see, it looks like we're going to get 6 times, I'm just doing it a different way, 15 times 25, and we get 2,250. What that means is 18 will divide into that, and so will 250. So this is the smallest number that 18 and 250 will divide into. So let's do the next one. We have 3 numbers. I'm actually going to zap this off so that I have enough room to do this. So you can always rewind or pause the video if you want to finish copying it. Zapping it off. Okay, let's do the next one. We are going to take 3 numbers and prime factor them. So 35 is pretty simple. 5 times 7. That's it. 60 is 2 times 30. 3 times 10. 2 times 5. And then 90 would be 2 times 45. 3 times 15, 3 times 5. Now if I wrote those all out, 35 would be 5 times, whoops, internet problem there. 35 would be 5 times 7. 60 would be 2. I did it in different order than I did before. 2 times 2 times 3 times 5. And then 90 is going to be 2 times 3 times 3 times 5. So, all right, now we're going to find our least common multiple. After you do that, hopefully everyone has this tree thing down by now, or whatever you do. Some of you like to do it like this, 35 divided by 5 is 7 kind of thing. That's fine. Do it however you like. So now we're going to find the least common multiple. So we need all of these numbers included, but if it's already in there, you don't need to multiply by it again. So I'm going to just start with the first one. We have 5 times 7. So these are included. Now I'm looking, are there any 2's? There aren't any 2's down there yet, so I'm going to add the 2 and the 2. Is there a 3 down here yet? Nope. So I'm going to put the 3 down here. Is the 5 down here? There's already 1 5. That's good. That's all we need. Okay, let's go to the 90. Is there a 2 in it so far? Yes, there's a 2. We can cross that out. Is there a 3? Yes, there's a 3. But this number needs another 3, so we're going to put another 3 on here. And is there a 5 already on there? Yes, there's already a 5. This number only has 1 5. There's 1 5 down there. So you're simply going to multiply those all together. And I did this ahead of time. So we get 1,260. And that is the number that all of these numbers will go into evenly. And it's the smallest number that they'll all go into. If we started listing out the multiples, like if we did 35, 70, 105, and then we did the same thing with 60, 60, 120, 180, 90, 180, etc. Eventually, the first common one that we would get would be 1,280, and you can see that would take a lot of work. So using this prime factorization is a way to find a least common multiple, which is the same thing as the lowest common denominator. So that is it for lesson 20. I hope you enjoyed it.